Hi, ladies and gentlemen. Welcome to another video. This time, we're going to go a little more in depth on some of the things that matrices can do for us. We're kind of building on some of the power that matrices have to see how they can help us solve these systems of equations. We're actually going to be building up and ramping up a little bit more each time we kind of watch one of these videos. But today, we're going to talk about is what's called row echelon form and reduced echelon form, which are going to be kind of the one of the main ways we're going to be looking at solving systems using a matrix. So we already talked a little bit about, hey, I can get an augmented matrix and use that to solve, but we're going to kind of move a little bit even further and say, can I make a matrix that just tells me the answer? Because that's kind of where we want to get leading to, okay? So row echelon form, okay, so let's see, right, okay, so row echelon form, which just put that there in that. My writing is really bad with the mouse, so just pretend that word's there. So row echelon form is the following properties. Basically, any rows consisting entirely of zeros are at the bottom of your matrix. So if you have a row that becomes all zeros, it just goes to the bottom. Each row is not consistent. Blah. Each row is not entirely zeros. The first entry will be 1, and then the leading one has a 0 in every row below it, and it's further to the left than the next row is leading 1. And then reduced row echelon form. Okay, so the reduced row echelon form is if all those things are true, and again, I'm just going to use this, going to go there. Okay, if all those things are true, but then that leading one is the only thing in the row and everything else is zeros. If you're like, Mr. Guy, what are you talking about? I don't understand what this means. Basically, what it means is that, sorry, technical glitch there for a second. Basically, what it means is that we're looking for the first entry in a row, the first element to be a 1, and then everything below it should be a 0. It doesn't really matter what's over here. We have a 2, we have a 3, we have whatever, but the first needs to be 1 and all zeros. And then for the next row, the leading one is a 1, and it's 1 over from the previous rows. And then everything below it is a 0, and then we can have whatever we want over here, blah, blah, blah. And in the final row, we have a 1, and then if we have an augmented matrix, we can have whatever the heck we want over here. Now, you'll notice that kind of the reason why row echelon form can be helpful is that it kind of introduces a back substitution system for us. Look, we have 1, a 1, a 1. I can solve this here, plug this in here, solve, plug this in here, and solve. So it kind of sets up that back substitution for us. Basically, I'm always saying we're looking for a triangle of zeros to show up right here. That's kind of our goal. This can also be true for the reduced echelon form. In fact, that's going to be even more powerful as we see, because for that one, not only do we want a triangle of zeros there, we also want to try to make a triangle of zeros here, and we'll see why that can be important in a moment. So this is what's called Gauss-Jordan elimination, where basically we try to get into reduced row echelon form, and then we use that in order to get the answer to our equation. So if you look here, I actually have a matrix that's already in row echelon form, okay? So it has all leading ones, it's got zeros underneath them, okay? And then the only thing that's there are the things to the right of it. What we're going to do is we're going to actually turn this into reduced echelon form and kind of see the magic that happens when we do that. Well, how do we get about doing that? What we're going to do is we're going to kind of use, basically what we end up doing is we use these ones that we created in order to get rid of everything else, because ones kind of make it easy to do stuff with. So I'm going to use the 1 here to get rid of all the y's in this row. And then I'm going to use the 1 here to get all the y's and all the z's gone in this column. Because remember, it's like x, y, and z. So basically what I'm going to do is I'm going to say, all right, to get rid of this up here, I'm going to do 2 row 2 plus row 1. And the reason why I'm using this row here is, A, there's a 1 there, but also because it does not have an x, so I'm not going to get rid of that beautiful 1 I have there that I want to keep. So let's see, what's that going to do when I do that? Well, so my new matrix, my first row is going to be 1, 2 plus -2 will be 0, which is what I want to have happen. 6 and 3 is going to be 9, and then 5 and 9 will be 19. The next row I didn't do anything to, so that's going to stay exactly the same. And the bottom row is going to stay exactly the same. I did not do anything to that one either. Now I want to get rid of these two z's. I want to make these both go away. So how am I going to do that? Well, I'll use this row right here. I have a 1, and that can get rid of these. So I'll do -3, row 3 plus row 2. And I'll do -9, row 3 plus row 1. And that's going to make it so I have that reduced row echelon form that I'm looking for. So my top equation, I'm going to have a 1, going to have a 0. -9 plus 9 would be 0, exactly what I want. And then over here, negative 18 and 19 will be 1. In my next row, I'm going to have 0. I'm going to have 1. Negative 3 plus 3 will be 0, which is what I want. Negative 6 and 5 will be negative 1. And then the bottom row, I have 0, 0, 1, 2. Now, this is a reduced echelon form. I have 1, 1, 1 down a diagonal, zeros below and above. Okay, cool. Mr. Guy, why did we take the time to do that? Because you may actually notice that this right here is actually our solution to the system. By doing this into reduced echelon form, we actually set up where the augmented part, this part over here, tells us the answer to what x, y, and z are. It's almost like a magic trick. If you want to see the logic behind that, remember that this is the column x, this is the column y, this is the column z. My first equation is just that 1x equals 1. It's basically telling me the answer, x equals 1. My next equation only has y, so it's telling me that y equals negative 1. And my last equation only has z, so it's telling me that z equals 2. Basically, somebody realized that if they had everything else become zeros and only left a single x, a single y, and a single z, they would be given the answers automatically over here for what the answer to the system is. So the answer to the system is going to be 1, negative 1, 2. And I get that by doing this Gauss-Jordan elimination, by turning this into a reduced echelon form. Okay, let's try another one together and see again how that kind of works. So again, I'm starting you off here with a matrix that's already in reduced echelon form. We're going to turn it into reduced echelon form, take it that extra step to see if we get the answer. Here's what I want you guys to do. I want you to go ahead and pause this video for a second. I want you to go ahead and try this one for me and see what you get. And then we'll come back together and we'll talk about the answer together. So I'm going to go ahead and pause the video as you should. I want you to go ahead, try that for me a little bit, and then we'll meet back together and make sure that we have the same solution. So ready, set, pause. All right, so hopefully you went ahead and you tried this one and tried to see if you get down into that reduced echelon form. So this will walk you through my steps. So what I did negative 2 times row 2 plus row 1. That got rid of this y value up here. So I had this row or this column kind of taken care of. And then for the last column, I did negative row 3 plus row 2 and 4 row 3 plus row 1. And ended up with this reduced echelon form. And my answer was negative 31 for x, 12 for y, and negative 3 for z. So that's reduced echelon form. That's how we would solve that. That's just another kind of step in the puzzle here of why these matrices can be so powerful and help us. Basically, we just created a matrix that tells us the answer. When we have this reduced echelon form matrix, that kind of gives us the answer straight away. Next week, what we're going to be getting into is kind of doing some matrix operations. So how do we add matrices together, subtract them, multiply, and that sort of thing. And eventually, what it's going to lead us into is some really, really powerful stuff where I can create a method using these matrices to solve any system that has any amount of variables in it. So we've been dealing with 3 variables and 3 equations. Eventually, we want to be able to solve more complicated systems like 4 variables, 4 equations, 5 variables, 5 equations, things that actually would be applicable to real life when we have a lot of different things that could change on us, and we want to find solutions for how to be the most efficient as possible when we're doing something, okay? So thank you for watching. Please go ahead and complete the work for the next 2 days, and I hope you guys are staying safe.